in this short video, I'm going to discuss inference rules in the derivation system. So there are really a bunch of kinds of moves we can make inside of a derivation. We can create things called show lines, we can make assumptions, we can apply inference rules, we can box and cancel show lines, and as we'll see, we can also write down premises. But we're going to be focused on the application of inference rules. So an inference lets you go from its premises to its conclusion. It's a small obvious step where, given the premises of the inference rule, we can get to the conclusion, and obviously so. So the idea is going to be that in a derivation, if you have the premises on a line, and if you have the premises of a rule on a line, then you can write down the conclusion on another line. And we're going to have 5 inference rules. These are their abbreviated names, and those are really what you need to know. I'm going to tell you what their full names are, but their names are MP, MT, DNE, DNI, and R. So what are these rules? So the first rule is modus ponens, MP. You say Bob is an emu. If Bob is an emu, then Bob flies, and Bob is an emu, so Bob flies. Is that a good step? Yes, definitely so. If the premises are true, then so is the conclusion. And what's the form in this argument? Well, we have a conditional, and we have the antecedent of a conditional as our premises, and we infer to the conclusion of the conditional. And indeed, if a conditional is true and the antecedent is true, then the consequent has to be true, and that's why this is a good rule. Now let's consider a slightly different argument. So here we say Bob is an emu. If Bob is an emu, then Bob flies, and we say our second premise is Bob flies. Now consider Bob is an emu. Does that follow from the premises? No, it doesn't follow. It might be true that Bob is an emu, but it might not be. He might be some other sort of bird, or a plane, or who knows what. So there are lots of ways that the premises could be true and the conclusion false. And this is not the same form as the inference of that we previously saw. In this case, the premises are a conditional and its consequent, and the conclusion is the antecedent. In the previous case, we had a conditional and its antecedent, and the conclusion was the consequent. So that's a good form of arguing, and that's modus ponens. Conditional plus antecedent infer consequent. This is a bad form of reasoning, so this is not modus ponens. Second rule is modus tollens, or MT. So we say, first premise, Bob is an emu. First premise, if Bob is an emu, then Bob flies. Second premise, Bob does not fly. What follows from this? Does anything follow? Well, we have a conditional as our first premise, and the second premise says the consequent of the conditional is false, and that means that the antecedent of the conditional is also false. This is a good form of inference. It's called modus tollens, or as I will refer to it, and as you can refer to it in the program, MT. And right, if the premises are true, then so is the conclusion. If the conditional is true, but its consequent is false, well, the antecedent has to be false as well. If the antecedent were true, then the consequent would be true, but the consequent isn't true, and so the antecedent isn't either. Okay. So let's consider another possible example here. So here we have, if Bob is an emu, then Bob flies, and Bob is not an emu. Does it follow? Does anything follow from this? Does it follow in particular that Bob does not fly? No, it doesn't. There are all sorts of things that Bob might be besides an emu and yet still fly. So this is not of the form modus tollens. So modus ponens is conditional plus antecedent. You infer the consequent. Modus tollens is conditional plus negation of consequent. Infer the negation of the antecedent. We have 2 double negation rules. Actually, well, they can both be referred to as DN, or we can refer to these more specific ones. So in the first case, we have, it is not the case that Bob is not an emu. So there are 2 negations there, and what follows from that? It follows that Bob is an emu. So this is double negation elimination, because in going from the premises to the conclusion, we eliminate 2 double negations. On the bottom, we have Bob is an emu as our premise, and the conclusion is, it is not the case that Bob is not an emu. And if that premise is true, so is the conclusion. This is called double negation introduction, because we're introducing 2 negations. So here are our rules in schematic form. We have modus ponens, where we have the conditional and the antecedent as premises. The conclusion is the consequent. We have modus tollens, where we have a conditional as premise, and the negation of the consequent as premise, and the negation of the antecedent as the conclusion. We have our double negation elimination, so if we have a sentence that has two negations on it, we can remove both those negations. We have double negation introduction, where if we have a sentence, we can put two negations on the front of it, and we can, in the program, the first rule is going to be referred to as MP. The second program is referred to as NT. Both of the double negation rules can be referred to as DN, and if you want to be specific about which one you're using, you don't have to. You can say DNE or DNI. And repetition just lets us repeat a line. We're not going to have use for that really right. Well, we'll have a little bit of use for that, but not immediately. I will explain how we use that when we do. Now let's see, that's not good. Let's see. So we're going to take a look at some rule recognition problems. So the point of these problems, is to help us. Oh, we're in the wrong module. Let's get over there. That's much better. Okay, here we are. So the point of these problems is to help us to learn to recognize the rules. You need to have the rules absolutely memorized. They're your tools. It's like if you go into a kitchen and there's just one knife there and you need to do some cutting, then that's the knife you need to use. And if you can't use that knife, it's just not going to work. So similarly, you need to know these rules. If you don't know these rules, they're your only tools you have. You'll be stuck. And none of these rules are extraneous. They're all essential. If you don't know all of them, they're going to be you will get stuck in some derivations. So it's not enough to know one or two. You need to know them all. Okay, so let's take a look at this problem. We have two premises. We have if not t, then if t, then u, and we have not if t, then u, and our conclusion is not t. And so the question is there a rule that applies here, or is there no rule? So what do you think? So the answer is that there is a rule, and the rule is modus tollens, because here we have a conditional, and what's its consequent? If t, then u. So the second premise is the negation of the consequent, and the conclusion is the negation of the antecedent. So that's MT, and that's what this says. So we can apply rules. The consequent doesn't have to be a sentence letter. The consequent can be as big as we want. It doesn't matter. If we have the negation of the consequent, then the consequent, however large it is false, and therefore the antecedent, however large it is also false. Okay, let's consider this. We have not if not p then w, and we have if p then w. So it's certainly not modus ponens or modus tollens, but it might be a double negation. In particular, it might be a double negation elimination. So is it? Well, let's find out. No, it's not. Why not? Because one of these negations is on the antecedent. It's the negation, or inside the antecedent, it's just the negation of p. And the other is the negation of the whole conditional. So this is not... Double negation elimination says you have a sentence and then two negations in front of that sentence. So if you had a conditional, if p then w, and you had two negations in front of it, then you could infer if p then w by double negation elimination. But this double negation elimination does not apply to this, because while there are two negations there, they're not both negations of the same thing. One is inside the antecedent, a negation of p, the other is a negation of the entire conditional. Let's look at this. So if this is, again, going to be any application of a rule, it's going to be double negation, and it would be in particular double negation elimination. So do you think it's double negation elimination? Well, let's find out. Yes, it is. Why? Well, there's the sentence not z, and we have two negations in front of the sentence not z, and we've gotten rid of two of them, so that's double negation elimination. Is this a rule? Not P, then not P. Indeed it is. It is the rule R. Okay. Did we accidentally start? Yeah. How about this? If T then S, then not if T then S. So this is double negation introduction. This is really, so if you look at the conclusion, you will say, look, we've added a couple things. We added both the negations, but we also added those parentheses. But actually, the premise is informal notation for parenthesis T arrow S parenthesis. And so we've we've only added two negations. Let's see here. So, is this modus ponens? No, because we don't have the antecedent as one of the premises. Is it modus tollens? Well, let's see. The conclusion is the negation of the antecedent, so that's right for modus tollens. Modus tollens also requires what? That we have what? We have the consequent, we have the negation of the consequent, we have the double negation of the consequent. Do you remember? In fact, well, let's see. Is it empty? No. Why not? Because we need the double negation of the consequent, and here we have, we need the negation of the consequent, but here we have the double negation of the consequent. So this is not an instance of modus tollens. Okay, how about this? Not, if P then Q, then not if P then Q. Is this double negation elimination? Well, it might look like it. I mean, there we have 3 negations at the beginning on the left side of the premise, and there we have 2, only 1 on the left side of this formula. But in fact, this is not double negation elimination, because double negation elimination says if you have a sentence, and you have two negations outside of the sentence, negations of the whole sentence, then you can write down just the sentence. But all 3 of these negations, these are both informal notation, right? They're conditionals there, so they're parentheses there, but they've been dropped. And the parentheses here have to go back around the whole thing, which means that these 2 negations are not negations of the conditional. They're 3 negations of P inside the antecedent. And this is a negation of just 1 conditional inside the antecedent. And so this is not an application of modus ponens. Now you could do a derivation of this argument, but it's not an application of modus ponens. It's an application, what you're doing is, in a sense, you think, oh, I'm applying double negation elimination to the inside of the formula, or the sentence. In general, you cannot do that. In fact, you can't do that at all in this course. You get to chapter 4, if you take the Philosophy 132, then you get a rule that sometimes allows you to do that, but now we can't do that, and there are reasons why in general you can't. In general, it's not a valid form of arguing. In general, when you apply a rule to the inside of a sentence, what you get does not follow logically. The premises could be true and the conclusion false. So the thing is, you have to apply the rule to the whole sentence only and not to its parts. And so this is not applying double negation to the whole thing, and you can't apply rules to the parts, and so it's not an application of any rule. As we say, none correct. Let's see, are there any others we want to do? Let's take a look at 18. So we have a conditional, we have the negation of the antecedent as our other premise, and the negation of the conclusion, the negation of the consequent is our conclusion. So, is this either modus ponens or modus tollens? Well, what do you think? In fact, it's neither. Modus ponens requires we have the antecedent and we get to infer the consequent. Modus tollens requires we have that our other premise be the negation of the consequent and we get to infer the antecedent. But this is, if we have the negation of the antecedent, can we infer the negation of the consequent? And that's not in general the case. So remember, let's say if I have a cookie, then I will be happy. Does it follow that if I don't have a cookie, I will be unhappy? No. Maybe if I don't have a cookie, I'll be unhappy. But if I'm in a good enough mood, then the fact that I don't have a cookie, I'll still be happy. So the negation of the antecedent doesn't imply the negation of the consequent. So we say none, and we check it, and we are correct. So let's just go back to our keynote, because there's one last thing I would like to remind you of, which is this. You need to memorize the rules. It's absolutely critical that you memorize the rules. If you don't memorize the rules, you won't know what your tools are. If you don't know what your tools are, you won't be able to use them. If you don't use them, you won't complete the derivations. So you have to memorize the rules. Okay? Yes? Good? All right. So we've talked about rules in this little video. In the next video, we're going to start using the rules inside actual derivations.